Hello and welcome to this learning video. In this learning video, we are going to take a problem on half-range cosine series and that too in the arbitrary interval. Okay, so let us see what this problem says. This problem says obtain the half-range cosine series for the function f of x is equal to 2x minus 1 in the interval 0 to 1. So instead of 0 to L, we have 0 to 1. So what is L? L is equal to 1. Hence show that this. For the time being, forget about the second part this. We first concentrate on the first part, okay, which is obtain the half range what? Obtain the half range cosine series for the given function. So what is my function? Let f of x is equal to 2x minus 1 in the interval 0 less than x less than 1. Okay, now write down the Fourier cosine series. So what is the required? Therefore, the required half range cosine series is what is it? F of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L. So here L is equal to 1. So here you can write cos n pi x. Okay, here you can write since L is equal to 1. Say this is to be my equation number 1 and say this is to be number 2. Okay, now what is a0 and an? Where a0 is 2 by L. So here L is equal to 1. So 2 by 1. Intentionally I am writing 2 by 1 to get the feeling of that 2 by L integration. Okay, 0 to 1 f of x dx, and what is my an? An is 2 by 1 integration 0 to 1 f of x into cos n pi x dx. Okay, so this is what we have. So let us find out a0 and an. To find a0. So what is a0? a0 is 2 times integration 0 to 1 2x minus 1 dx. Okay, that is a0 is equal to 2. What is integration of 2x? 2 x square by 2 minus x 0 to 1. This 2 get cancelled. So we have 2. 1 square is 1 minus 1 0. Upper limit 0 minus 0 0. So here I am getting my a0 to be 2 into 0. So a0 comes out to be lucky number 0. Now let me find out this an. Okay, so what is an? An is equal to 2 integration 0 to 1. What is my f of x? 2x minus 1 into cos n pi x dx. Okay, so here you can apply the integration by parts. Okay, and try to get the result for an. So an is equal to 2. What is integration of 2x minus? Okay, applying integration by parts over here. So this is 2x minus 1 as it is into integration of cos is sine n pi x divided by the coefficient of x n pi limit 0 to 1 minus derivative of 2x minus 1 is 2 into integration of this. So this is minus cos n pi x by n pi already there and n pi. This is n pi square limit 0 to 1 and now apply the limits. So this is 2 into, when you apply the upper limit, so this is 2 into 1 minus 1, so this is 1. Sin n pi is 0, then lower limit sin 0 is also 0, so this gives you 0 minus 0. This minus minus become plus 2 upon n pi square. Here this minus minus become plus, now you can apply here, so this is cos n pi minus cos 0. Okay, this bracket complete. So what is my an? My an comes out to be 2 2s are 4, n square pi square, cos n pi is minus 1 to the power n, cos 0 is 1. This is my an. Where is the pen? Yeah. So this is my an. Now after getting this an and a0, you can substitute here in equation number 2 to get the first part. Okay. This equation 2 becomes, so after substituting the values of a0 and an, this equation 2 becomes f of x. What is my f of x? 2x minus 1 is equal to a0, 0 by 2 plus summation n is equal to 1 to infinity. What is an? An is this, 4 by n square pi square into minus 1 to the power n minus 1 into, what was that? This is the cosine series, so cos n pi x. Okay, this is my result. If you want, you can write it more precisely by removing this term of 0 by 2 as 0 and no need to write there. So you can write here like that is 2x minus 1 is equal to, you can take this term to be outside. What is this? 4 by pi square. So this is 0 plus 4 by pi square into summation n is equal to 1 to infinity 1 by n square into minus 1 to the power n minus 1 into cos n pi x, and this is the required half range cosine series for 2x minus 1 in the interval this. Okay, but this is just the first part, hence first part. Now see the second part. In the second part we have to deduce this result, so you can write here second part. So what does second part says? Say this is to be equation number 3. Okay, so for second part I am gonna make use of this. Okay, so can just write here, put second part, put x is equal to 0 in equation 3, we get, so the moment we put x is equal to 0 in equation 3, what will we be getting? We will be getting 2 into 0 minus 1 is equal to 4 by pi square summation n is equal to 1 to infinity minus 1 to the power n minus 1 upon n square into cos 0. And everyone knows what is cos 0. Cos 0 is 1. So you can solve further. So this is minus 1 is equal to 4 by pi square. Here it is summation of n is equal to 1 to infinity minus 1 to the power n minus 1 upon n square. Cos 0 is 1. Okay, now take this to the left. So this is minus pi square by 4 is equal to, now remove the summation and take values n is equal to 1, 2 and so on. So the moment you take n is equal to 1, so this is minus 1, minus 2 by n square. So this is minus 2 by 1 square. Plus take n is equal to 2, minus 1 square is plus 1 minus 1, 0, 0 by 2 square. Then minus 2 by 3 square. Plus 0 by 4 square. Plus minus 2 by 5 square. Plus and so on. Okay. Now taking this minus 2 common and multiply it to this 4. So this becomes pi square by 8 is equal to 1 by 1 square, 1 by 3 square, 1 by 5 square plus and so on. Hence the second part. Clear? So I hope this problem is clear to you. So you can just go through it and try to solve this problem. And if you have any doubt, you can ask your difficulties. Okay. So thank you for watching this learning video and enjoy learning mathematics. Thank you.